Welcome in, everyone. I'm so thrilled you're joining us today. Whether you are prepping for a highly technical meeting, maybe catching up on some reading during a commute, or just carving out some time to explore a complex concept, you are definitely in the right place.
Absolutely.
We know your time is super valuable, and our goal today is to pull some compelling, in-depth insights from a really particularly dense piece of source material.
We really do have a fascinating document on the table today. We are looking at a translated Japanese blog post that operates right at the intersection of theoretical physics and philosophical critique.
Yeah, it's quite the combo.
It really is. The author uses the handle Zionad 2023, and the post itself is titled Draft, Mr. Einstein Slacking 116.
Such a great title.
Right. It is a highly eccentric, deeply technical exploration of geometric optics and relativity. And, it goes deep.
The premise alone demands attention. This author is leveling a serious critique at how modern physicists visualize space and time.
A very serious critique.
Yeah, the central argument revolves around the geometry of information delay. The author suggests that by failing to fully internalize the simple fact that light takes time to travel from an object to our eyes, well, we have fundamentally distorted our baseline understanding of reality.
Exactly. The critique is really built on the idea that observers in physics are too often treated as these instantaneous receivers of information.
Like they just instantly know what's happening everywhere.
Right, which just isn't true. The author argues that we need to stop looking at the universe as this flat, immediate map and start accounting for the staggered, messy reality of light speed limits.
And the way they illustrate this is amazing. It's through this series of highly creative, almost surreal analogies and thought experiments.
Oh, they are so creative. I love the analogies in this piece.
We are going to navigate through all of those today. We will be looking at everything from the cognitive load of a tennis player to physicists acting like wizards to a very specific scenario involving a character called the Train King.
The Train King is my favorite part.
It's so good. By the time we trace the path of these arguments, the goal is to understand why treating the universe like an instant snapshot might be a critical error in how we conceptualize physics. Okay, let's unpack this. Where do we start?
Well, the author opens with a very grounding, real-world visual. The analemma.
Oh, right, the analemma.
Yeah, so if you set up a camera in Tokyo pointing south and you take a photograph of the sun at precisely 12 noon every single day for a year, you don't just get a single dot.
Right.
When you overlay those 365 images, the sun traces this glowing figure-8 shape in the sky.
It really is a beautiful representation of the Earth's axial tilt and its elliptical orbit.
It is a striking image, but the author uses it as a bit of a trap.
A trap, yeah, because we look at that figure 8 and we think, oh, we are seeing the mechanics of the solar system perfectly mapped out.
Exactly. But that image is just a two-dimensional projection. It completely flattens the z-axis.
It strips away all the depth of space.
And by stripping away the depth, it completely masks the time it took for that visual information to actually reach the camera lens.
Which is the crucial oversight, right? Because to illustrate this, the author constructs this hyper-specific timeline of information delay.
Yes, let's go through that.
So picture a transparent hemisphere dome surrounding the Earth. According to the breakdown in the text, it takes light roughly 8 minutes to travel from the physical surface of the sun to just hit that transparent dome.
8 minutes just to get to the dome.
Right, and the journey is staggered from there. The author breaks the final leg down even further to emphasize the multi-step nature of observation.
It's not instantaneous once it hits the atmosphere.
Exactly. It takes another full second for that light to cross from the transparent dome to the pupil of your eye.
1 whole second.
And then there is an additional 0.1 second delay just for the light to travel from the opening of your pupil to physically strike your retina, which finally initiates the neurological process of sight.
What's fascinating here is, when you stand outside and look up at the sun, you are completely decoupled from the present moment.
Completely.
You are processing a photon that left its source over 8 minutes ago. And because the Earth is moving along its orbital path...
Or from our local vantage point, the sun appears to be moving across the sky.
Right, exactly. Because of that motion, the physical current location of the sun is entirely divorced from the glowing image that's actually hitting your retina.
The math the author provides on this is honestly sobering. Because of that 8-minute transit time, the actual physical mass of the sun in the present moment is offset by approximately 2 degrees from the visual representation you see in the sky.
2 degrees is a lot, in astronomical terms.
It's huge. If you built a theoretical laser that could travel instantaneously and you aimed it at the center of the sun you currently see, you would miss the actual sun entirely.
You'd shoot right past it.
Yeah, you have to aim 2 degrees ahead of the visual data just to hit it.
Which means we are constantly operating inside a delayed projection. And this delay forms the foundation for the first major analogy the author uses to critique theoretical physics.
The tennis net.
Yes. The author returns to that transparent hemisphere dome we just mentioned, the boundary between the observer and the incoming light, and compares it to a tennis net.
I love this part because it shifts the focus from the object being observed to the cognitive state of the observer.
It grounds the math in human experience.
Exactly. So imagine you are playing a high-stakes tennis match. That net is the boundary where delayed information crosses into your domain. When you are on the court, you cannot afford to be a passive camera.
You'd lose instantly.
Right. First and foremost, you have to track the ball, which represents the delayed visual data arriving from your opponent's racket.
But tracking the ball is only a fraction of the equation. You are player one. You have internal variables to process simultaneously.
Your own physical state.
Yes. You have to calculate your own stamina, your footwork, your physical capacity to intercept that delayed information before it passes you. Your field of view is forced to rapidly oscillate between the external data and your internal reality.
And the author broadens the scope even further. The player's field of view might temporarily shift to the umpire to check a call, or to the crowd in the stands, or even momentarily register the corporate logos on the perimeter.
It's a very noisy environment.
Perception in a physical space is an incredibly dynamic, shifting, and highly contextual process. You are embedded in the messiness of the delay.
You are part of the system.
But the author argues that modern physicists systematically reject this reality.
They do. The critique pivots sharply here. The author claims that instead of operating like the tennis player, who acknowledges they are an active participant bound by the rules of delay and physical limitation, physicists attempt to act like wizards looking into a crystal ball.
Wizards looking into a crystal ball, it is such a deliberate choice of words.
It paints quite a picture.
It does. A wizard draws a circle on the ground, steps completely outside of it, and assumes a godlike objective view of whatever's happening inside the crystal ball.
They remove themselves from the rules of the world they're watching.
Exactly. And the author points out that physicists simulate this wizardry by drawing out a coordinate grid, placing their theoretical observers on it, and pretending they can observe the entire system from the outside. They assume the role of a transcendental observer.
And by placing themselves mathematically outside the universe they are measuring, they treat reality like a static diagram spread out on a desk. They think they can look at point A and point B simultaneously.
Which we know is impossible.
Right. To hammer this home, the author introduces the general staff officer analogy, which I think isolates the flaw perfectly.
Oh, the bunker scenario. Let's look at that. You have a military officer stationed deep underground, completely removed from the physical battlefield.
Safe in their bunker.
Yeah. And they are staring at a massive tactical map. When they receive a report, they move a blue flag to represent their troops and a red flag to represent the enemy.
Simple enough.
Right. But in the mind of the officer, the instant they slide that flag across the paper, the reality on the ground has updated. They believe the map is synchronized with the present moment.
But the officer is suffering from a massive blind spot. They are entirely ignoring the messenger.
The delay.
Yes. They are ignoring the exhausted soldier who had to physically sprint across a hazardous, muddy battlefield for an hour just to deliver that intelligence.
By the time the officer actually moves the flag, the information is already obsolete.
Exactly. And in the author's framework, light is that messenger.
Yeah.
When theoretical physicists look at their coordinate grids, they are just moving flags. They are completely disregarding the transit time of the photon carrying the visual data.
Here's where it gets really interesting. To prove that this bunker map mentality fundamentally fails to describe reality, the author constructs a highly detailed thought experiment involving a character known as the Train King.
We need to set the parameters of this scenario precisely as they are laid out in the source text.
Let's do it.
Imagine a train car. For the sake of the geometric calculations, the author assigns this train a total length of 20 units.
Okay, we have a 20-unit train. Positioned exactly in the middle of this train, sitting on the floor, is our first observer, whom the author calls the department head.
Correct. Now, attached to the very center of the train car, directly above the department head, is a towering vertical mast.
Going straight up.
Straight up. High up at the top of that mast, sitting in a crow's nest, is our primary observer, the train king.
The train king.
And finally, standing far away from the tracks, completely removed from the train's local environment, is a third observer called the referee.
It is a very distinct hierarchy of observation. So to establish the baseline, let's look at the physics when the train is completely stationary.
Okay, the train is parked.
If a flash of light is emitted from the very front of the 20-unit train, and another flash is emitted from the very back at the exact same time, those light rays travel up to the crow's nest.
Up the mast.
Right. Because the train is at rest, the light from the front and the back travels the exact same distance and reaches the train king's eyes simultaneously.
The geometry in that stationary state is perfectly symmetrical. If you draw it on a piece of paper, the paths of the light form a clean isosceles triangle.
It's very neat.
Very neat. This is the comfort zone of the general staff officer looking at the bunker map. Everything is synchronous.
But the scenario changes drastically when we introduce relativistic speeds.
Yes, it does.
We're going to accelerate this train until it is moving at 0.6 times the speed of light, or 0.6 c.
Which is incredibly fast.
Yeah.
And if you were the physicist acting like a wizard outside the crystal ball, you look at your map and simply slide the entire drawing of the train forward along the x-axis.
You just move the whole picture.
Right. Your map implies that because the light sources and the train king are both on the train moving together, the light should still hit the king at the same clean 45-degree angles. You assume the local geometry remains undisturbed.
But the map completely fails to predict the physical reality the train king actually experiences.
Because of the message of...
Exactly. Because light has a finite speed, it takes time to travel from the floor of the train up to the mast. While that light is traveling upward, the train and the mast and the train king are rapidly moving forward at 0.6 c.
So the light doesn't just go straight up anymore.
No. From the king's perspective, the incoming light ray has to contend with multiple vector components. We have to break down the vector addition here because this is where the static map just shatters.
Let's do the math.
The speed of light is a constant c, but because the train is moving horizontally at 0.6 c, the light ray traveling from the front of the train up to the king has its vectors split.
It's moving diagonally.
Yes. It has a horizontal component matching the train at 0.6 c. Which means, according to the Pythagorean theorem, its vertical speed component traveling up the mast is 0.8 c.
Because 0.6 squared plus 0.8 squared equals 1.0, or c squared.
The math is inescapable.
It really is. And what that means for the train king is profound. The light isn't coming in at a symmetrical 45-degree angle anymore. The forward momentum of the observer essentially drags the apparent origin point of the light.
It pulls it forward.
Exactly. The text points out that the angle shifts dramatically, hitting the king's eye at exactly 36.87 degrees.
So the geometry physically stretches, the triangle warps. The reality the train king observes is physically distorted by the combination of information delay and their own high-speed motion.
The bunker map completely masked this 36.87-degree distortion because it assumed the information arrived the instant the event occurred.
Which we know is the fundamental flaw. And the author grounds this theoretical math in a very real historical precedent. James Bradley's discovery of stellar aberration in the 18th century.
Oh, this is a great connection.
Yeah, Bradley was trying to measure the parallax of stars, but he found that the stars actually appeared to shift their position in the sky depending on the time of year.
The classic analogy for stellar aberration is walking in the rain.
Right.
If you are standing perfectly still and the rain is falling straight down, you hold your umbrella directly over your head.
Makes total sense.
But if you start sprinting forward, you will get wet if you keep the umbrella straight up. You have to tilt the umbrella forward to intercept the raindrops, even though they are still falling straight down relative to the ground.
Your forward motion changes the apparent angle of the incoming rain.
Exactly. And Bradley realized the exact same principle applies to starlight. Because the Earth is orbiting the sun at a high velocity, an astronomer has to tilt their telescope slightly forward along the vector of the Earth's orbit to successfully catch the photons coming from a distant star.
So the train king's 36.87-degree visual distortion is the exact same phenomenon, just scaled up to relativistic speeds. Observers in motion see a skewed universe.
They absolutely do. And this realization sets the stage for the climax of the author's critique.
The big finale.
Having established that motion distorts the angles of delayed information, the author applies this framework to one of the most foundational experiments in modern physics, the Michelson-Morley experiment.
To understand the impact here, we have to visualize the equipment they used. The Michelson-Morley experiment utilized an interferometer.
A big word for a cool device.
Right. For our purposes, just imagine a large, perfectly circular disk. A light source in the center fires beams outward to mirrors located on the perimeter of the circle, and those mirrors bounce the light back to a detector in the center.
The original goal was to measure variations in the speed of light.
Right. But the author takes this circular interferometer and places it squarely on the floor of our moving train right next to the department head.
Okay, so it's on the floor.
It's on the floor. Now, the train is rocketing forward at 0.6 C. The question posed to the reader is, how does that perfectly circular device look to the train king, who is sitting high up in the crow's nest, receiving the delayed light bouncing off the edges of that moving circle? So what does this all mean?
It means the train king does not see a circle.
Not at all.
When the light fires from the center of the interferometer, it travels out to the edges. But remember, the entire circle is moving forward at 60% the speed of light.
It's hauling.
Right. So the light beam heading toward the front edge of the circle has to chase a mirror that is rapidly moving away from it. It takes longer for that light to reach the leading edge, bounce, and travel up to the crow's nest.
Conversely, the light heading toward the back edge of the circle is traveling toward a mirror that is rushing to meet it head-on.
It's closing the distance.
Yes, so that light completes its journey and reflects up to the train king much faster. The information from the trailing edge arrives before the information from the leading edge.
The arrival times are heavily staggered. Now, a physicist looking at a standard coordinate map might assume that relativistic length contraction simply squashes the circle into a symmetrical oval.
Like a neat little egg shape.
Right, but the author actually modeled the paths of these delayed light rays using a 3D rendering program called Blender. They wanted to simulate the precise geometry of what the train king's retina would receive.
And the Blender simulation reveals the ultimate punchline of the blog post.
It's so brilliant.
Because the delay is fundamentally asymmetrical, longer for the front, shorter for the back. The shape doesn't just compress into an oval. The visual data warps into a highly asymmetrical teardrop or streamlined shape.
Teardrop.
Yeah. The leading edge of the circle appears rounded, but the trailing edge stretches out and tapers off like a droplet of falling water.
If we connect this to the bigger picture, the author is leveling a devastating critique at the methodology of the era.
Devastating is the right word.
The argument is that physicists were so heavily reliant on the clean, synchronous math of their Cartesian grids that they completely failed to account for the temporal realities of the Michelson-Morley apparatus.
They obsessed over the behavior of the light inside the interferometer, but they forgot to calculate when the visual evidence of that light actually departed the device and arrived at the eye of the observer.
They treated a dynamic, severely delayed system as if it were a static, instantaneous snapshot.
The Blender simulation proves that the teardrop shape is the physical truth of what an observer would actually see if they were bound by the speed of light.
But the math on the theoretical paper, generated by wizards standing outside the crystal ball, insisted it was a neat geometric shape.
The overarching takeaway here is that there is no such thing as a transcendental observer.
You cannot step outside the universe to measure it.
You are always player one on the tennis court. You are always the train king in the crow's nest, constrained by the physics of delay, forced to view a world that is heavily skewed and teardrop-shaped by your own momentum and position.
It fundamentally destabilizes how you think about observation.
Which brings this massive relativistic thought experiment right back down to your daily reality. Why does a deep dive into Japanese physics blogs and train kings matter to how you operate today?
It serves as the ultimate, mathematically proven reminder of the adage, the map is not the territory.
Think about it. When you are looking at a complex financial spreadsheet or reading an aggregate news report about global supply chains or reviewing data dashboards in a board meeting,
You are looking at a bunker map.
you are. The data you are analyzing is inherently delayed. It is shaped, constrained, and sometimes severely distorted by the specific vantage point of how and when it was collected.
You're always receiving information from the past.
It is incredibly easy to fall into the cognitive trap of the general staff officer. We look at our screens, and we subconsciously assume we possess an instantaneous, godlike view of our projects or our industries.
We assume we are wizards outside the crystal ball.
But we aren't. The messenger is always still running across the muddy field. The data is always lagging behind the reality on the ground.
Acknowledging that delay and anticipating the 36.87-degree distortions in your own data is what separates a passive observer from a strategic thinker.
You absolutely have to account for the transit time of your information.
This raises an important question, one that builds directly on the author's desire to discard static coordinate grids and create a new framework based entirely on the actual paths of light rays reaching a specific individual.
It is a radical way to reorient how we think about space.
It is. If every single piece of visual data you process, from the sun burning in the sky to the traffic light changing on your commute, right down to the micro expressions on the face of the person sitting across from you.
All of it.
If all of that is technically an image transmitted from the past, and if your definition of now is entirely locked to your exact physical coordinates in the universe,
Is it ever truly possible to share the exact same moment in time with another human being?
that is the question.
That is a staggering implication. Are we ever genuinely occupying the same now, or are we all just sitting in our own isolated crow's nests, processing our own uniquely delayed versions of reality?
That's a lot to process.
It is a profound, somewhat isolating, but endlessly fascinating thought to leave you with. Thank you for joining us today and lending your time to this exploration. Keep questioning the maps you are handed, and we will catch you on the next deep dive.